How's everyone doing? Good? Okay, cool. I was kind of disappointed to see it started raining a little bit, and I was kind of wondering if anyone was going to try to 3D print some umbrellas. But I actually think that's one of the most interesting uses of 3D printing for a lot of environments where you're not actually sure what you're going to need until you get there. See, most of you didn't bring umbrellas, I didn't. And I think that eventually we're definitely going to be in a world where you won't ever have to worry about bringing an umbrella. I'm the co-founder and the chief strategy officer of Made in Space. We're putting 3D printers in space. And today I just want to talk to you guys, we good? Okay, a little bit about what we're doing and how it really affects everybody here. So normally when I talk about Made in Space, really one of the big focuses we normally talk about is the advantages of going to space, how it's a huge industry worth hundreds of billions of dollars, and all the benefits that it has for everybody here on Earth. Today I want to focus a little bit more on just the capacity that space has to inspire people. I think probably everybody here has read at least a science fiction book or two, watched a few movies, and probably dreamed at some point in your life of doing something in space. If not only a dream at night, just lying in bed thinking, maybe one day I'll be able to go, maybe one day I'll be able to do something that actually impacts space. But the problem is, really our whole lives, space has been something where there's a barrier between us and there. It's like you look up and you think, okay, astronauts are up there, they get to go do things in space, we have to stay down here, maybe we can think about it, maybe we can design things, but we've never really been able to get to this world. This is actually a concept from the 70s of O'Neill from Princeton, of a space colony. It's the future that we've all dreamed about, living in space, living off of the resources gathered in space. And I think sometimes we all wonder, why hasn't this happened yet? Why aren't we actually living in a world like this? And the problem, when it really comes down to it, is that space is really, really expensive, really risky, and really difficult. You're talking about 10,000 pounds or more, or sorry, $10,000 or more per pound, long multi-year time cycles of innovation, huge amounts of risk. It all comes down to really the fact that it's really expensive and difficult to launch things into space. And that puts a huge dampening effect on innovation. How are you going to really do something that impacts space if you can't get there? And I think that the problem really comes down to the fact that there aren't really any hacker spaces or places that people like you and people like us can get together and actually do something that impacts the space industry. It's a shame. And it really it dampens the innovation. And it's not hard to see that if it's going to take you millions of dollars and years to do something, that the cycle of developing technology for space is just going to be really, really slowed down. Good news is there is actually something like maybe one hacker space in space. Of course, it's the International Space Station. And it doesn't actually look that different from your typical hacker space that you all know and love, except, again, the hundreds of billions of dollars that go into it and the fact that it's very difficult to actually get anything there. And what we're doing at Made in Space is we're changing that. Very soon, actually, there's going to be a much better way to get things that you want into space. And I guess you already guessed it already. It's 3D printing. So the paradigm shift that we want everyone to understand is, instead of launching things to space, just print it there. Why would you go to all the energy to build it here and then launch it when you can just build it there? So I'm just going to say a little bit about our company so you know where we're coming from. We're putting the first 3D printer in space next year in 2014 on the International Space Station. And that first printer is going to be capable of printing about 30% of the spare parts on the International Space Station. We were founded in 2010 really with this core mission of opening access to space. We actually didn't start with 3D printing even. We started looking at the problem and the challenge and saying, well, look, space is difficult to access. How can we take an emerging technology and really open up access using it? We're at NASA Ames Research Park, which is at Moffett Field in Silicon Valley. We've got about 25 employees with really a focus on space systems and advanced manufacturing. So how did we get it to work? How did we actually get our 3D printing technology to a place where you can use it in space? That's the question that we always get. Basically, we've been following this plan that we outlined at a space manufacturing conference in 2010. In 2011, we did our first initial milestone studies on additive manufacturing and microgravity. In 2012, we spent most of our time designing and building our printer for space. And now in 2013 and 2014, we're going to be flying our printer to the space station for really everybody to use. So how do we do it? This is actually me in the lower right, floating in a zero-G aircraft. It's some of the most fun that I've ever had. NASA actually contracts a few different companies to take you on these flights where you fly up and down in a parabolic arc, and you get these little moments where you simulate microgravity for about 20 seconds. So originally, when the company was founded, we thought, okay, we want to put 3D printers in space to enable access to space. That was our goal. So we acquired a few dozen off-the-shelf 3D printers. They were state-of-the-art at the time, everything from your cheaper MakerBots to your more expensive commercial high-end printers. And originally, we thought we were just going to fly these printers to space. So we contracted with NASA to get the funding to go on these flights and try them out. We took the printers on there, and I guess we were partially surprised, partially not surprised to find out that none of them actually operated properly. Zero gravity and microgravity have quite a number of strange effects that you can predict some of them, but not really all of them. Every day we find out when you take things to space that technology performs differently than we thought. So we started modifying these printers over the years and doing what we could to go on these flights, test them, take them down again, modify them, take them up again over hundreds and hundreds of parabolas to get them to really print properly. Problems we were addressing were the obvious ones: print quality, internal strength of the parts. And finally, we ultimately were able to come up with a design of a printer that works completely independently of gravity. So it ended up in a way that we made so many modifications to the existing printers that we eventually realized it was better to just develop our own printer from scratch, which is what we have. So it's not just a zero gravity, and I'd love to spend time focusing on more than just that, but there's really a laundry list of things that you have to do to get a printer to work in space, everything from safety, dealing with the off-gassing, crew interaction, the communications between ground and station. It's a whole process, really. And we've been working with a big board of people at NASA. Probably over 100 engineers at NASA need to review these things before they can be safe for crew use on the station. So we have two initial missions to the ISS. The first one is quite creatively called 3D Print. And we're partnered with NASA to do that. It's manifested for launch on SpaceX 5 in 2014. And really what that's going to be is a demonstration of the technology. It's going to be a proof of concept demonstrating that the research that we've done over the years does actually work, and that we can actually 3D print in space. And then the following year, we're going to be launching our permanent manufacturing facility to space so that anyone can really use it and print things in space. So I do want to talk a little bit about that, and that's actually going to be the focus of the rest of my talk, is how this really affects everybody here. We view what we're doing, not to use too much of a cliche analogy, but a little bit like the iPhone or any other platform analogy. We want to be the ones that are doing the hard work of putting things in space so that it can be easier for you guys. If you remember earlier what I was talking about space being such a hard industry to enter, because how are you going to actually get anything on the space station effectively? But once our printer's there, we are actually going to be opening it up to the world to print things in space. So if any of you come up with any ideas, something you think that would be good for science or exploration or diversions, fun and games for the astronauts, whatever it is that you come up with, we can help you put it there at really the click of a button. So of course, the basics, spare parts, repairs, and emergencies, this is the one that everyone jumps to first. You have an Apollo 13 type scenario. What do you do? Right? Well, if you have a 3D printer on the space station, you just print the fix immediately. It's much faster, much safer. That one, though, is, I think, where a lot less creativity is. So on to more of the things that we think you might want to make. Tools are a big thing. So this is a common thing that you'll see on the space station. Because it's so hard to get things there and it takes so long, astronauts will find a toothbrush, tape it to something, and go ahead and use it for whatever purpose they need, which is quite resourceful. But there really hasn't been that much innovation then from people, again, like the community here, for developing better solutions than this for problems that come up on demand. So I definitely want to encourage everyone to start thinking about, now that you can actually put things in space, what kind of tools would you develop? What kind of problems would you want to solve? Experiments are the big thing. The space station is, at the heart of it, a large experiment, completely in and of itself. You could think of it that way. It's pushing the boundaries of what we know for science and exploration. And so most of what goes on the space station actually is experiments. And even now, you're starting to see people on the ground 3D printing their experiments and then launching them to space and getting radical decreases in the amount of time that it takes to create those experiments and the amount of money that it takes. But we know that once our printer is on the space station, you're going to be able to come up with all sorts of really cool experiments that we can just print right there on demand and do them. And I think one of the things that we're most excited about is actually experiments that leverage the unique properties of zero gravity. So this is something that I think is going to really become big in the next few years after we have our printer there, because if you think about it, anything that you design for space still has to exist on the ground while you're building it. So first you have to build it on the ground, and you have to take into account the fact that that 1G, the gravity, is present. So already you're actually over-engineering what you're designing for a use case in space, because in space, whatever you make is not going to have to actually withstand any gravity at all. Of course, there's going to be little forces coming here and there, but nothing like 1G. But on top of that, everything that you launch is going to have to withstand up to 9Gs in the rocket. Crazy vibrations. So if you look at everything that's designed for space, it's way over-engineered, vastly over-engineered, really just for that first 8 minutes of its existence while it's launching into space. And then for the rest of its life, it doesn't have to be affected by any of those forces. So this has been a big limiting factor in designing things for space. Pretty much everything that's in space is over-engineered. And so I want you to just think about what you could do now that we're going to have 3D printing capabilities on orbit. For the first time, you're going to be able to design things for space that actually don't ever have to exist in a gravity-based environment. That's going to allow for huge reductions in mass, but not only that, you could get some pretty interesting capabilities and functionalities out of it if you start thinking about what could you really do if you don't even have to design for the existence of gravity. And the reason I have this listed as an experiment is that no one's really ever done this before. We see this as one of the areas that we're really enabling, pioneering. We're working with a number of universities right now who are starting some studies on this. But we really want to kind of wake you guys up and get you thinking, really, what does what does design in zero gravity actually even look like? Because it sort of requires, just like designing for additive manufacturing in the first place already requires a paradigm shift for a lot of people who've been trained traditionally. This shift is yet another shift in that direction. And we see the uses of our printers in the beginning as just doing a lot of fundamental research on what does it actually mean to build things in an environment where gravity is not even present. Art is an interesting one that it gets ignored sometimes, but it really shouldn't be. This is a sculpture some of you have probably seen made down here where parts of it are 3D printed. But really, we're also looking for people to design the first artwork to be printed in space. It's going to be the first art ever to exist, again, in a zero gravity environment. So not just engineering benefits, but also artistic benefits. We've talked to a number of artists who are very excited about the possibility of being able to design in an environment where there's no gravity. So that's something else I'd encourage everyone here to think about. Upgrading existing experiments is huge, so it's not that hard to do some basic research and see what's going on station now. And we've already gotten some pretty interesting ideas from individuals just like you and me who've been looking at the experiments that are up there and saying, hey, you know what? If we had something that was a little bit like this, we could turn experiment A into experiment B and do something totally new and different for a fraction of the cost. And so we've been talking to a few people already who want to print those modifications. And again, really the thrust of the message I want to make here to everyone, if I'm successful, is that you really can start to think about this stuff. As makers and as designers and creative thinkers, you all now can look at an experiment on the space station and say, what if we modified it a little bit like this and did this research? Satellites are a big topic. Who here knows about CubeSats? Okay, good. So about half of you. So satellites are getting smaller and smaller these days. That really just has to do with the same reason that iPhones and other smartphones are powerful in their size. Computing power is getting faster and faster, cheaper and cheaper, smaller and smaller. It's enabling really small satellites about this big to have the same power sometimes as much larger satellites. They're called CubeSats because they're shaped like a cube. And you can 3D print a large amount of these satellites already. As the technology advances, it's going to move more and more towards printing entire satellites on orbit. But even with our initial printers, we're going to be able to print parts of CubeSats on orbit. So even if you guys have an idea for a satellite mission, let us know, because we might be able to do it faster, cheaper, and just easier than any other way that was possible before. And we're really excited about the possibilities for education. I don't think any talk about space or 3D printing would be complete without this point. Space obviously has a tremendous capacity to inspire an entire country to develop science and technology programs. Kids are enthralled by space, as well as 3D printing. So we're really looking forward to the day when we can take a version of our printer to a classroom along with a laptop, have a kid design a part, push a button, print it in space 20 minutes later, and have an astronaut actually holding that part that the kid designed. So if there's any teachers in the room that want to get involved with that, we'd love to hear from you. And sort of an offshoot from that is what we think is going to be possible for just globalizing and democratizing space for everybody. Space really, up until now, has been something that only the wealthiest of nations have been able to engage in. There are countless countries that have never even put something in space before, and we see our platform as a possibility for those nations to actually, as a first shot, put their first part in space and then eventually their first satellite. So what we're doing is really enabling space access across the board to your average person, to students, to academics, to children, to really people around the world. And my call to you is, what do you want to make in space? Like I said, our first printer is going up next year, and the next one's going up after that. And we're really ready to hear from you. I'd love to hear ideas, concepts, thoughts. What do you want to make? Our team has over 100 combined years of space mission experience and experience with 3D printing technology. And we see ourselves as the ones who are going to be doing the hard work of figuring out how to get things into space. And then once we have the manufacturing technology there, you can use it. So this is our tagline that we've kind of been playing around with in the office. It's not official yet, but it might be. Email your hardware to space. You can visit our website. You can email me. That's my personal address. Or if you want to just come around to our lab, it's in Silicon Valley, Mountain View, NASA Ames Research Center. Shoot me an email. You can stop by, hack around on our 3D printers, and just in general have fun with it, realizing that space is now one step closer to being accessible by everyone. Thank you. So I think I was told there's a little bit of time for questions, if anyone has any. Yeah, sure.
What are you printing in?
So our first printer is an ABS system. We're starting with that just because it's obviously the simplest and easiest to do. It is an extrusion-based process. That's for the technology demonstration that's going up next year. And then after that, for our 2015 printer, we're actually looking at quite a number of advanced materials, space-grade polymers. So it's going to be accelerating pretty quickly after that. But we're starting with the ABS. Someone over here had the second. Yeah. Okay. Yeah.
Is the 3D printing material recyclable?
Yeah. It's a good question. So we are aggressively developing recycling technology in our lab. The material, I mean, it's the same materials that you're using down here. A little bit down the line, we have some special materials that are designed for space. But let's just leave it at, if it's recyclable down here, it's going to be recyclable there. There's the added challenges of getting a recycler to work in space, but that's something we're working on as well. Yeah. Great question. I love that. Okay, so there's actually, so the question was, how is it actually more cost effective to do this if you still have to fly up the raw material? It's a brilliant question. So there's actually a lot of reasons why. One of the biggest reasons actually comes back to the fact that when you're launching things to space now, there's so much risk involved, and it's such a one-shot game that you have to make everything incredibly redundant. You have to send countless spare parts, whereas if you can manufacture there, you don't have to worry about that. And that actually ends up being a really huge deal, right? You'd think maybe it wouldn't be, but most of the stuff on the space station is actually spare parts. So the same goes for your experiment. If you spend 2 years designing an experiment, and then you finally get to send it up, and you spend $1 million to do it, and then it finally gets there and it breaks, you're in trouble, right? So you're going to send a lot of redundancy with it. You don't have to do that anymore once you can 3D print on orbit. There's actually a lot of answers I could give to this, but just to keep it brief, the other big one is the thing I touched on, where when you're designing things for space, you don't have to design them in an environment where gravity is ever present. So, because in space there's no gravity, so things don't have to support their own weight. And if something doesn't have to support its own weight, it can use much less material to achieve the same function. So that's another reason. And there's actually, recycling is another reason. Yeah, there's a bunch, but cool. Okay, yeah. After the proof of concept? During the proof of concept. So during the technology demonstration, we're going to be printing a series of test coupons to test all sorts of material properties of how the prints actually operate in space. It's really it is a science experiment, just as with every other experiment on the station. But we are actually also going to be printing some tools and even some CubeSat parts, and assuming that everything goes well, actually using them. But the primary function is gathering material or data on the materials and the properties and the internal structural strength of what we print. Yeah.
So when you go to microgravity, like you're thinking about like intermolecular forces that normally you wouldn't care about because gravity would just tear it apart. Like with van der Waals and things, have you guys looked into how things hold together in space differently than they might here?
Yeah, absolutely. I mean, you're completely right. You know, the physics of how things hold together, and especially the dynamics of fluids and all sorts of things like that are very different in space. So, yeah, I mean, that's actually like one of the primary focuses of our engineering team, is understanding how all the different properties of what happens in space affect the 3D printing process, and then designing a printer that takes into account those differences. Absolutely. Yeah. Yes.
So for like the first couple versions, it sounds like there'll be like a lot of research going to material science. Is there anything in the timeline for more advanced printing of stuff like conductive materials, critical circuitry? Is that like on the timeline?
Yeah, it absolutely is. So we have a pretty big R&D arm. I mean, I guess it's arguable that we're almost all R&D, although now transitioning into actually delivering our product to station and opening up our service to everybody. But yeah, we really stay up to speed on just about every 3D printing technology that's developing terrestrially. And then what we do is we look at uniquely how to make them operate in space. So actually, if any of you are working on 3D printing technologies like electronics or conductive materials, we have partnerships with a number of universities who are pioneering that stuff. But if any of you guys are working on that, we'd love to look at how we can put it in space. Maybe you'll even get a flight on one of our zero-G aircraft. So yeah, absolutely. Okay. Anything else? Great. Well, thank you, and please do email if you have any ideas for things you want to put in space, or if you want to come hang out. Either way, we'd love to work with you. What we're doing is we're bringing space to everybody. So have a great rest of your day. Thanks.